Hi, good afternoon everyone. Welcome to this Intrinsic webinar on Webinar Tuesdays. I just want to check that everyone can currently hear me. Yep. If you can't hear me, if you just leave a comment and just let me know if you can't, and then we can make some adjustments. Okay, so I believe everyone can hear me. So let's get this webinar on the road. So, welcome to this webinar is based on structural validation in 3DEXPERIENCE, which will be presented by me, Amit Patel. So a little bit about myself before I begin. I graduated from Cranfield University in an MSc in Aerospace Vehicle Design. My undergraduate was in aircraft engineering. I've worked at Intrinsic for just over 4 years now. So prior to that, I did a work placement in Turkey, so working at a manufacturing plant where they used to manufacture pneumatic valves for agricultural use. So I was operating and programming CNC machines, and then I spent the second half of my internship working at a consultancy based on doing Tier 3 level Airbus drawings. So my key roles here at Intrinsic are training, so I get involved with training. I do training in FE, CAD, methodology, etc. One of my primary roles is support, so if I support clients, any customers with difficulty with licensing, software implementation, or just after-sales software support. And I also get involved with pre-sales, so I help our sales team demo CATIA 3DEXPERIENCE functionality or any other Simulia products as well. So that's a little bit about me, but what about Intrinsic? So Intrinsic was established back in 1998 as an engineering consultancy. They themselves were just using Dassault system products, later approached by Dassault to actually start reselling their products. Okay, so essentially it's a PLM consultancy. It operates alongside engineering businesses and is the UK's largest and best resourced Dassault system business partner. So recently we did win an award for being the biggest business partner in Northern Europe, in whatever region Dassault defined as North Europe. So we're all pretty proud of that. The company itself, the PLM side, employs around about 64 people with a turnover of over 12 million. And the engineering consultancy side has just over 85 engineers with a turnover of over 20 million. So there's quite a lot of broad things we do. We not only sell and support software, we also actually use the software ourselves in a live engineering environment. We currently have 4 offices in the UK and 1 in South Africa, so we have 5 offices worldwide. Okay. The PLM side, essentially, the software we support is 3DEXPERIENCE platform, so that's what I'm going to do my webinar based on today. So the webinar itself is going to be based on the 3DEXPERIENCE platform. The particular platform I'm going to use is the cloud, which we'll talk about when we come to it. CATIA, so CATIA V5, V6, CATIA 3DEXPERIENCE, Inovia, so the data management side, Dalmir, so the manufacturing side, Simulia, which is again, I'll be demoing Simulia, part of 3DEXPERIENCE, the most basic form of Simulia, so simulation toolset, Exelead, so search-based optimization, Transcat, IMS Post, Ramsys, and some other software as well. Consultancy side, so we do implementations and project management, so we do all of this in-house. All our implementations and projects are managed in-house, and then software deployment and also after sales support as well, so training and help desk as well. Okay. Again, it's probably worth noting our help desk as well isn't primarily just for anyone software through us, it's for anyone using Dassault system products. So the design consultancy, we take concept all the way through to detailed design. We look at material and process selection, prototype supply and component testing. We do our structural analysis in-house as well. It's not something that we take out of house. So any software we sell, as you can see, we actually use the software and are more than familiar with it. And our expertise of press tool design, styling, patent design and research, casting, fixtures, vehicle installations, you name it, one of us here has done it. Okay, so we usually have a specialist in one area within our organisation. So let's go into what actually 3DEXPERIENCE is. This is the actual platform I'll be using. So 3DEXPERIENCE is actually a business experience platform. It's an all-in-one software solution. So it's collaborative and interactive. It has a collaborative and interactive environment. You find everything related to a product lifecycle on this platform. So not only does it house CAD documents, it can also house other documents such as PDFs, Word docs, anything that supports preliminary design of anything, and also for sales, purchasing, etc., etc. So 3DEXPERIENCE is an all-in-one business experience platform. So things it can do like 3D design, analysis, simulations, and it's just a general intelligent software. So the 3D design side will obviously be CATIA, so that's where we do our CAD design. Analysis will be the Simulia side, and when we have simulation intelligence. And it's on premises, so what that means is that there's a server housed on site, and then you have all your client machines pointing to that server. And you can have public or private cloud. So cloud is what I'll be using today. So what cloud is, it allows anyone to access information from anywhere, as long as they've got an internet connection. It's particularly good for maybe that one-man band. It's even quite good for large organizations as well. So rather than having to set up VPN access to on-premises version, so having to access the server, you can access it from anywhere around the world. All employees, you will have your own private cloud or public cloud. Everyone accesses that, and you can share all your information, etc. on there. Okay. So the security side, again, is managed by Dassault themselves. They host the cloud. So now we've seen what 3DEXPERIENCE is, what exactly is Simulia? So Simulia is a multi-physics analysis and simulation side of Dassault systems. So you can imagine Dassault systems broken down into CATIA, that's the CAD side. We then have Simulia. With Simulia you could do linear, non-linear analysis, or simulation it's also called, fatigue, optimization, etc., etc. So before 3DEXPERIENCE, this was primarily done in separate applications. So you could do linear, non-linear using Abacus. You could do fatigue using SAFE, optimization using EyeSight, optimization using Tosca, and you could use EyeSight for process design. Okay, but now using the 3DEXPERIENCE platform, it can all be done on one platform. So 3DEXPERIENCE itself gives users access to roles and apps. So it's not like you download 3DEXPERIENCE and you have access to everything. Essentially what you would do, you'd buy licenses. In 3DEXPERIENCE, people actually purchase roles, which are essentially licenses. So for example, you could buy a stress engineer role, which will then give users access to various different apps. So roles are essentially licenses, and the roles give user access to various apps. So for example, the stress engineer app gives the user access to the structural validation app, which is what I'll be demoing through this webinar. Apps are essentially known as workbenches for anyone that uses CATIA v5, where they're called workbenches, and it allows users to perform different actions, so modeling, simulation, collaboration, etc., etc., life cycle changes, and so on. So the reason why we have these apps is because you don't just have one application with the capability to do everything all in one page, essentially. So different operations are broken up into different apps. For example, if you want to analyze a part, do you really want to be able to see the tools in order to build an assembly, for example? So you switch between the apps. So the apps and roles itself, when it comes to 3DEXPERIENCE, just looking at the Simulia side, there are various different roles and apps. So let's have a look at the roles here. We can split these up when it comes to Simulia into 3 different subdomains. So we have like multi-physics modeling and simulation, simulation-based design, and simulation process and innovation management. So for example, I'm not going to go through all of these. So the fluid mechanics analyst, so it permits them for a seamless switch between applications. It enables users to apply the right tool at the right time in their workflow process. So it essentially allows them to do fluid CFD sort of analysis. Okay, again, we have structural vibration analysts, so it's used for advanced linear static and linear dynamic simulation techniques. So again, having this role will then give the user access to the applicable apps in order to perform their actions. Okay. Just taking another one, so the stress engineer role, which is the most popular one that people tend to purchase with the 3DEXPERIENCE platform. The stress engineer role, okay, it provides simulation-based guidance during product design to improve product performance. Essentially, it's kind of aimed at designer level. Is to allow designers to quickly validate their designs and understand how that particular model will actually work. Okay, so it's just study their own products, etc. It's not really. There will be a analyst level role available. Okay. And then you have for composites, etc. So you've got composite simulation engineer and so on. So the role that we're going to actually be using is the stress engineer role, which will give me access to the structural validation workbench. So this is the MDS license that we have, which gives the stress engineer role. And in the 3DEXPERIENCE platform itself, looking at the compass in the top left corner, you can find all your simulation-based apps under the South Compass node, so VR. All CAD-based roles are found on the left, so using 3D. If I turn on my stress engineer role, it then gives me access to this structural validation workbenches. The available tools for me at the structural validation app, I can make connections, very basic connections. I can create very basic restraints, loads, and then manipulate the results. So the main aim of a structural validation app is for designers just to come in with their model, think, well, hold on, how will this work in the real world? What kind of loads, what kind of stresses will I get out of the model if I apply certain loads? Could I get away with using maybe a lower grade aluminium? Do I need a higher grade aluminium, etc., etc.? It just helps them quickly validate what they're modeling. Now, so even though it's aimed at designer level, it's obviously recommended they have basic FE knowledge. So they don't need to have quite advanced knowledge. They have no interaction with having to create meshes, modify meshes, or anything like that. It's just bring in a model, load it as it would be in real life, constrain it or restrain it as it would be in real life, run the analysis, get a result, bam. Determine if it needs modifying, make the changes, run it again, done. So it's meant to be very quick, easy and fast. So that's the main aim of a structural validation app. So as I mentioned, the things all that the design engineer needs to ensure is that they have geometry, which goes without saying, have material applied to the geometry. Okay, so that's where CATIA uses the mesh and determines the stiffness through the material. Connections are a maybe. So if it's a single part, there are obviously no connections. If it's an assembly, there will be connections. Restraints, so how would the part be restrained? Loads, what loads will be applied? So these are mechanical loads. And if there's any thermal conditions, we can apply thermal loading as well. Good thing about the structural validation app in 3DEXPERIENCE is you actually get a checklist. So as you can see from this slide, 3DEXPERIENCE itself sort of says, have you got this? Check, yep. It gives you a tick. So in my example here, I've got a material. So I've got a tick next to it. Connection. Currently, if I have a look, it says a connection may be defined. It says maybe because if it's a single part, possibly connections aren't required. Restraints, so you can see I haven't finished building this model. It says restraint must be applied, and it gives me an example of a restraint I can apply. Same with loads, so a load must be applied. You can see an example for loads. Results aren't available yet in my example because I haven't actually simulated the model. And currently it's not ready for simulation because I haven't got any restraints and loads. So it's always telling you what it wants you to do. You can't really miss anything out with the structural validation app. So it makes it easy for designers to quickly throw out an FE result. You've also now got a manager as well. So it helps you visualize rather than having to go through the specification tree or graph, whatever you like to call it. You've now got a simulation manager. So you've got 3 nodes along the top. You've got model, scenario, and results. Under model, you'll see the part or the assembly and its corresponding parts under it. And you can see the material definition. Scenario, so that's everything used to build your simulation. So the FE analysis, so it could be a clamp, like a restraint, it could be a load, etc. And then under results, you've got all the results visible to you once the simulation has been simulated. There is still a specification tree, or graph as you like to call it. So the simulation itself has its own node, which is saved in the Innovia database. So that's the entire simulation file. And what that will contain is the model. So under the model node, you'll have your actual part or assembly with its corresponding materials applied. You'll also have a scenario, so the type of simulation. So scenario is not only how static stress simulations or frequency simulations, thermal simulations, it can also do kinematic simulations, machining simulations, etc. So they're all stored on the scenario node in 3DEXPERIENCE. And then under results will be your simulation results. So in this case, I'm getting the results of my static stress simulation. But you could also have a video output of your kinematic simulation, etc. So the structural validation app itself isn't just limited to linear static analysis. You can do frequency analysis, thermal analysis, and thermal structural. Okay. You can't do non-linear static analysis, so that's reserved for a more experienced role. But for a stress engineer, if they just want to throw something in, say will perform a linear static analysis is usually sufficient for designer level stress analysis. Okay. So yeah, we can do thermal as well. The other thing we have to note, for anyone that's new with 3DEXPERIENCE or V6, there are 2 types of materials. So we have access to a core material and a covering material. Just as a side note, each part can have 1 core material but 3 covering materials. They are just as they sound like. The covering material has no mechanical properties, it's just render properties. So maybe like I don't know, paint applied to a part, maybe a sticker, something like that. But all we're interested in as analysts, or designer level analysts, is the core material. So the core material gives us the mechanical properties. So you can see in the tree we have our aluminium, in this case core material, and it has various different domains. So it's got a rendering domain, so how the material will look, material domain, but the one that we're interested in is the simulation domain. So that houses the material's behavior, so such as for fatigue, damage, mechanical. So in our case, we're interested in elastic properties of a material. We also have access to different types of connections. So if we want to analyze an assembly at designer level, we can use contact. So we can say something is bonded together, it'll be as if it's glued, or if it's general contact, so something that isn't currently in contact but may come into contact during the analysis. So you can see here without general contact it penetrates. Perform a rigid connection. So in this instance, let's say if two items aren't mating, if they were mating together, we'll just create a bonded contact, but in this case, let's say they're not mated together, we can create a rigid contact between them where they'd sort of be fixed to one another. Again, we can add stiffness to the rigid connection by using spring, where we define the stiffness in various directions. We can do pinned, so if something rotates about one another, and we can also create different sort of bolts, so a bolt type connection as well. So what I'll do at this stage, I'll show you this operation using 3DEXPERIENCE. So this is 3DEXPERIENCE as it is. I'm using the cloud. Okay, so all I've done is access the cloud platform and asked to use the structural validation app, which then loads up the client on my machine. Now all I've done here is I've imported, so if I go to add content and imported a CATIA file, and this is an actual file I've created in CATIA v5, which I'm going to use to demonstrate. I've then uploaded it to the cloud. It's not a very large file, so it didn't take too long, and this is what I've got. So let's start off analyzing just one single part. So this is a symmetrical part about this axis. If I have a look at the part as it is, I've got a solid body which has aluminium applied to it. So anyone that hasn't seen the 3DEXPERIENCE platform before, everything is stored in the Novia. The searches, we can perform searches along the top, and we find all the tools on the bottom toolbar. So unlike V5 or on V6 where you have tools down the right hand side, here depending on what app you're in, you get different tools, and the toolbars are split up by tabs now. So rather than using a transform toolbar, I've got a transform tab. Okay, and I've displayed everything nice and easy, so you can take all this off and it's a bit harder to navigate, but I like to have all my labels on so I know what I'm picking. Now to change, I'm currently in the Part Design Essentials app. That would have been called the Part Design Workbench. I want to go into Structural Validation Workbench. I'm just going to go press the south compass. I can use my Stress Engineer role. I can see what apps they have available, or I've got 5 roles, I've got them all turned on, and that in total gives me access to all of these apps. So I'm going to use structural validation for this webinar. Okay. So just click on that. So now, the first thing that's been displayed while I enter the structural validation workbench app, is what type of simulation do I want to perform. So is it structural, frequency, thermal, structural. So I'll be showing you how to perform the structural and frequency cases in this webinar. So let's start off with structural. Press OK. Okay, so it says here your CAD contains some items that simulation does not support. So these are basically, I've got some surfaces or some reference geometry in there. Okay. So I'll just OK to that. And there we go. Now I'm in the structural validation app. So using my simulation manager, which I can move around, what I'm going to do with it is I'm going to dock it onto the left-hand side, just like these two tabs, and I'll just drag it and drop it. So it's quite good. You can tidy up how your whole application looks like. If I go to the model, you'll see I've got one model. Now someone's going to ask, well, where is the model tree? It's actually hidden, it's still there. So if I press F3, I can bring my model tree up again. I can move this slider and so on. And you can see this is the actual simulation object which gets stored in Novia, which contains my model, scenario and results. So at the moment I don't have a result, I've got my model, which is this part. You can see there's a finite element model associated to it now, so that would be the mesh, which I've got no control over under structural validation workbench. And then my scenario in this case, which is my static stress simulation. So all I'm going to do, if I go to static stress simulation, I've got a material connection, so it says a connection may be defined. I don't need a connection. I need to apply a restraint. So this is a symmetrical part. So I'm going to go to restraints, and I've got access to clamp, planar, slider, hinge, and so on. So I'm going to, essentially what I could do is add planar, so I'll just show you how this planar symmetry works. If I select this face, it then knows normal to that face, there's planar symmetry applied to it. Okay. Again, if I go to my simulation manager and go to my scenario, you'll see I've got my symmetry restraint. Now I've got a restraint, so it says restraints have been applied, but I need to add more, so I'm just going to clamp the base. Okay. And then you'll see under my simulation manager I have two. I'm also going to now apply a load. So I've got my restraint, I then need to apply a load, so I'm just going to go to loads, apply a force in this hole, and I'm going to say in the direction, let's do, whoops, is it? Let's just move that round. Whoops, I think I just messed that up. Okay, let's just move that compass round. And I'm going to apply a load in, not that way, in, say Z, and a load of 500 newtons. Okay, so there we go, there's my load in Z. So it's as if it's been pulled off a wall that it's been fixed to. Okay. So I've got my load, got my restraints. It now says ready for simulation. So all I would do is go to results, select simulate. Now here is where it sort of determines what's going on with your mesh. At designer level, we're not really interested on the mesh size, so we can say whether it's draft, good, better, best. So that automatically defines the simulation accuracy, and the way it does that is it just refines the mesh. So draft will be quite a coarse mesh, and as we go on to best, it will be more of a fine mesh. So let's just do draft for the sake of this. Okay. Now you can see it's just checking my simulation model. Okay, now it's at 100%. And then once that's done, it should be any second now. Sometimes we get this as well. It says not responding. It's because it's working in the background. There we go. So our simulation is completed. So if I close that, you can now see we've got a results. Let's just move that aside. And if I go to my simulation manager, if I go to the results tab, these are all the results I can view. Okay. So let's look at von Mises stress. I get a tree. I can move that around. if I double click on that, I can change the colors, the decimal places, it's scientific or decimal, etc. So let's do that as auto. I can do min and max, show ISO contours, smooth colors or non-smooth, reverse. I normally say for reports and stuff, I like to use smooth colors, but as an analyst, I actually want to see where the transitions are between the boundaries, so I take smooth colors usually off. And you can do a vertical legend as well. So to move the legend around, we can just click on it, and then it's just like moving the graph. Okay. I can do a cut section, so you can see I can do a view cut, move that around, rotate it, keep that on there. Again, and remove it, and so on. Okay, so you can just move that so it snaps to particular faces where you want to cut the section view. Okay. And again, you've got all the properties to cut that, to define that section. Okay. We can play an animation, so how this deforms. Okay, again, if I go to settings, I can increase the number of frames. Okay, so I can slow it down, put it on repeat, etc., etc. Okay. So I have very basic access to the FE tools as at the structural validation stage. Okay. I could also modify the view, so let's just get rid of the play. If I right click on the actual view itself, I can go to plot type and show it as symbols. I could then modify the plot type, so if I go to change the plot, so if I just double click on one of them, so if I double click on one of the view, I can set view the lowest value. Let's do highest, it'll probably be easier to see. So there we go, so local max, local min, I'm going to say, let's turn that off, choose a density, so whether I want to see all the lowest, the highest, the size of the nodes. You basically have access to all these options. Okay, scale factor, show deformation, turn deformation off, you can hide the model, etc., etc. So let's just change the plot type again to contour, just as we would like. So that's basically an easy way to modify the structural analysis. I can then go back to the part and make my modifications. So quickly, if I just go to one of the pockets, let's say this hole, I can then modify that to, let's say, 5, for example. Okay. There we go. And then I can just go and ready to simulate. So what's happened here is results are out of date or incomplete because I've made changes to my model. So if I activate the simulation again, it then gives me access to simulate, and I can rerun the analysis. You guys get the idea. So it's very quick and easy for the design engineer to validate their results. So let's just get rid of this now. Let's have a look at an assembly. I just want to show you how easy it is to build connections. Okay. So in this case, again, I'm going to go down to the south compass, structural validation. I'm going to do a structural case in this instance. Okay, yep, okay, there's some reference geometry there, so that's what the warning's about. I like to show the tree, so I'm just going to press F3. And if I just go to my simulation, it says all my materials are there, but just for the sake of this, I'm just going to go back to the product and remove a material. Okay, so I'm going to remove the steel from the bolt. Now if I go back to my simulation, it says only 3 out of 4 materials are present. So if I go to the setup tab, so this is to set up my model, I can go to materials palette, I can search for the material, so in this case I don't need to, I've got aluminium, and then I could just say apply, or it could just be as easily as drag and dropping. So I prefer the drag and drop technique, it's very easy. Remember, it has to be a core material, okay, so it can't be a covering material because it needs to have mechanical properties. And there we go, now it says all 4 materials are available. Now this is the good thing about 3DEXPERIENCE. I can just go to contact detection. So here I've got 5, oops, let's get rid of that. Sorry, 4 parts in my assembly, 1, 2, 3, 4. So I've got a pin, a bolt, something that it's fixed to, and the actual lug itself. I'll go to contact definition, search domain the entire model, find surface pairs, and it's found 3. Okay. So one of them looks like it's the underface of the bolt and this top face. The next one's is actually the bolt in the hole. You can just about make that out. Then the other one is the bottom of the lug to this top face. Now the one I'm missing is an actual rigid link between, because they're not actually in contact or penetrating, it's missed it off, between the pin and the lug itself. So I'm going to create a rigid connection between there and between those faces. And that's my contact and a connection defined as well. So I used a rigid connection to connect those two. Now, my simulation manager, you'll see I've created 3 objects now. Okay, so I've got 3 bonded contacts. I'm then going to apply a load. So I've got my connection. Actually, in fact, let's do restraints next. I'm just going to clamp the base of this part. Okay, and I'll just add planar symmetry to these faces. Okay, so it does it in the direction normal to it. Now I'm just missing a load, so I'm just going to add a load on this face in Z. Actually, in fact, let's do it in let's rotate around X by 45. I wanted it the other way, so let's do minus 90. There we go. So it's applied in that direction. Force of 500. Let's do 1 kilonewton. You can see it automatically updates the units. And according to my static stress simulation, I'm ready to compute. So if I run the analysis, so results tab, simulate. Now this may take a little bit longer to analyze, so we'll just do draft again. I should have changed the performance to faster, just so we're not all here sat watching the entirety of this simulation. I think there's someone just behind the desk just turning a handle. They must be getting a bit tired now. It's taking a bit of time to compute. And there we go. It's quick. Can't fault it. Okay. Play my animation. Again, you can slow it down through the options, etc. Let's close that. I can do a show min and max values. And you can see you've got these toolbars here. So you can say just show me max, just show me mins, so there's 2 mins, or show me both, or show me none. Okay. And you can also edit them as well, so what values you want to see. Okay. So let's go back to none. Okay. So it's quite useful whenever you pick a tool, the options float around the cursor itself. Go to display groups, so I can say don't display the entire product. I just want to see the cleat, or the lug, should I say. And then it'll just display the lug. Or if I want to see 2 items, apply, it shows me 2, and so on. Okay. And again, I can see the displacement vector, reaction force, and again on the displacement vector I can modify that by just changing the plot type. Okay. Then I can switch back to the model by going to Setup and just selecting Results Visualization. So this will let me view the model itself, and I can go back and create connections, restraints, loads. If I'm in Results Visualization, you'll see all of these are grayed out because I'm visualizing the results. So just click on Results Visualizations, which should be available to you in all of these tabs. Okay. Now that's just a basic, and again you can modify the assembly and just simulate again. You don't need to build the loads or anything up again. Now just the final demonstration I want to show you is one of the frequency. So I'm just going to open up, let's say, the cleat itself, or the lug. Let's open it in its own window. And again, I'm just going to go to the structural validation app, and this time I'm going to choose frequency. Okay. Just OK to that warning again. And you can see here, I'm ready to simulate already for free frequency analysis. If it's just a, so it'll be like if it's floating in a vacuum. And rather than try and go to results and simulate, I can also select simulate from the simulate toolbar. Okay, so that's the simulate preferences. So I can pick the modes, the ranges of the frequency, etc., etc. Run the simulation. So for something that's actually on the cloud, the simulation actually runs fairly quickly since it's got to process it and store the data off-site. So I'll just close the report. And I can plot the displacement. And again, the first 6 frequencies we can ignore, so you get translations along X, Y, Z, rotations around X, Y, Z. And then it's the ones after the first 6, you can see the different modes and at what frequency these natural ones occur at and how it behaves. Okay. And it's as easy as that. So that kind of concludes my webinar. I have used a couple of references in order to build my webinar here. So this is Dassault Systems website, 3ds.com. Please visit that for more information as well. I've used some of the training material in order to pinch some images to make it easier for you guys to understand what I wanted to explain. So again, I reference the DS training material, particularly the companion online learning space, which us VARs have access to. So what can you do next if you want to learn a bit more? Well, a couple of things you can do, or a few things shall I say. You can visit our blog. So you might see there's a few blogs from me, Arik Patel. I'm a keen blogger for Intrinsic. I regularly like to submit blogs. It keeps our marketing department happy, and it also gets us pizza, so we carry on doing that. But if you go to intrinsic.com/blog, you can see weekly hints and tips. So it's not just for Simulia, it could be for CATIA modeling, it could be licensing hints and tips, and it will generally help you get more out of software that you're purchasing, or just learn more about a software you may be interested in. If you have this, if you're interested in formal training, you can visit intrinsic.com/training. So we do both on-site and classroom-based training. We can also supply hardware, and we have a variety of training courses available which have various different durations. So please visit our training page and to learn more about what we can offer you. If there's anything that we haven't covered and you'd just like to get in touch, or maybe you're interested in a bespoke matter or anything like that, you can just go to intrinsic.com/contact, and there you can submit a query through our web-based form. Other ways, you can join us on Twitter. We have a YouTube channel, and we're also on LinkedIn as well. So you can keep and stay informed and up to date with what us as Intrinsic are doing, hear about future webinars or future events through them as well. Right, so thank you guys for listening. Rather than end the webinar, I'll actually take some questions. So if you have any questions, feel free to type them in the chat below, and I'll answer them as I can. Okay. Any questions I can't answer, what we'll do, we'll take a note, and then we'll contact you later with the answer. Okay. So I'll just await all your questions. Okay, guys, I think that will conclude our webinar. Thank you guys for listening. I hope you found it informative and useful, and we look forward to having you join us again for our future webinars. Okay, thank you.